Okay. So see. So our question is about armature resistance control. If you read the question, you will understand. So what is the question saying? A 200 volt DC shunt motor. So what is the voltage? So given is voltage is equals to 200. Okay. So that is the given voltage. Right. So given voltage is 200 volts. Clear. Next. Shunt motor running at 1000 RPM taken. So N is how much? 1000 RPM. Taken an armature current of 17.5. So armature current of 17.5 amps. It is required to reduce the speed to 600. So we need to reduce the speed. So here this method helped us to reduce the speed. So I am saying it as N2 not to have confusions, because I have two speeds. It can confuse me. So I am trying to name differently. So N1, N2. This is the first speed. Now it has reduced it to 600. So N1, N2. What must be the value of resistance to be inserted in the armature circuit? So what should be the value of resistance to be added in the circuit? Because armature resistance control method means armature resistance control method means we are having resistance. Okay. Okay. So here what I am going to do, I am trying to, which is added as the extra resistance, because armature control method means what we are doing, we are adding extra resistance. So this is how the circuit will be generally. The green one is the general circuit. Okay. Even this is the general one. Armature will have minimum resistance. So this is the general system we have. Now we are adding extra resistance to reduce or increase the speed, right? So that is what they are asking. What is the extra resistance you added? That is the question. Okay. So inserted in the circuit. If the original armature resistance is 0.4, means original armature resistance is how much? 0.4. So here the green resistance is 0.4. What is the extra resistance you added? That is the question. Sorry. So now we want to find what is the extra resistance we have added to the circuit. Okay. Then take armature current to be constant during the process. They are saying armature current is constant. Why they are talking about that? Because you see, first case, when the system is there, how it is operating? Voltage is 200, speed is 1000, armature current means in the first case armature current is 17.5, armature resistance RA1 is 0.4. So current, resistance, speed, voltage are this in the first case. Right? Now second case. What is the second case? System is behaving like this. You understood that you can't control the speed. So now you added extra resistance so that you can reduce the speed. Now what is it? Input is not changed, but speed has reduced to 600. They said armature current should be constant, means IA1 should be equal to IA2, because the condition said armature current to be constant during the process. So as it is constant during the process, we are making IA1, IA2 same. Now they are asking what is the added resistance, means RA2 is nothing but RA1, right? Already we have 0.4. To that we added some other resistance. Clear? We are having RA1 0.4. To 0.4 we added something. That one has formed as RA2 and made the system to reduce to 600. Are we understanding? So IA1, IA2, RA1, RA2. So the question is about what is this R? I want the additional R. So at this case, the formula we learned from machines is N2 by N1 is equals to EB2 by EB1 into phi 2 by phi 1, means flux 2 by flux 1. So case 2, case 1. Okay, right? Now, what is speed we have? What is speed we have? Flux, we will talk about it. Then EB2. So what is EB1? Means back EMF. That is the back EMF. Back EMF formula is V minus IARA. I am talking about first case. I will talk about first current, first resistance. Okay. Same way, EB2 is equals to V minus IA2 RA2. So now, what is my V? Already the input voltage is given as 200. So 200 minus IA1 is how much? 17.5 into RA1 is how much? They said it is 0.4, right? So we will calculate this value. So 200 minus 17.5 into 0.4 we should be calculating first to know the value. So what is the answer? It will be 193. Okay. So this is 193. Now this is V is 200 because input won't change. Okay. Next, IA2 is 17.5 because they said armature current is constant, but we don't know RA2. So leave it like this. Then, as they said, armature current is constant. The meaning is flux is also constant. Okay. As IA1 is equals to IA2, phi 2 is equals to phi 1. So our formula will be N2 by N1 is equals to EB2 by EB1 because phi 1, phi 2 will get cancelled. Now I will substitute the values. N2, what is N2? 600. What is N1? 1000. What is EB2? We have it here. 200 minus 17.5 into RA2 divided by EB1. The back EMF is how much? 193. Okay. So send this side. Cancel 0, 0, 0, 0. 6 divided by 10 is 0.6. 193 will go this side. It is 193 multiplication, which is equals to 200 minus 17.5 into RA2. So 193 into 0.6, how much? Let me use the calculator. 193 into 0.6 is 115.8. 200 is big, this is small. So I will, okay, let me not confuse you. So this is equals to 200 minus 17.5 into RA2. Next, I will bring this side small value. I will bring RA2 this side. So 17.5 into RA2 is equals to 200 minus 115.8. Okay. 200 minus 115.8 is 84.2, which is equals to how much? 84.2. Therefore, RA2 is equals to 84.2 divided by 17.5. So, divided by 17.5 is equals to 4.8 ohms. Right? So, I got EB1, I got EB2. I know that these two are same. So, my formula has reduced to this. I substituted the values. I know all the values except RA2. So, I have found what is my RA2. Right? RA2 is 4.8. Means in the second case, my resistance is 4.8. But what is RA2? What is RA2?